competition is sponsored by AG+, the universal key to greatness.
AG+ turned my physics grade from failing to passing.
I hung my AG+ on the fridge.
I framed my AG+ and gave it to my grandma.
You can collect your AG+ in all shapes and sizes.
AG+, changing the world one physics grade at a time.
Hi, and now we're back to the Ride to Your Stomach Screams competition. All drug charges have been dropped. Now we can get back to the competition. Let's interview a passerby about the intense fun that's been happening so far. Hi, what do you think about the competition so far?
I think the competition is pretty intense. I just wish I knew how it all worked.
Well, it's got a lot to do with the physics concept of energy.
No way! Maybe they know something about the conservation of energy principle. Or maybe our competitors. Rachel and Courtney, the girls that never hurl. What can you tell me about the energy concepts involved in roller coasters?
Well, I know that roller coasters work on the conservation of energy theorem. This states that energy cannot be created or destroyed, but can be changed from one form to another. At the start of the roller coaster, work is done to bring the roller coaster to the top of the first hill. As this roller coaster gets to the top, this work is changed into potential energy, and as it begins to descend the hill, this potential energy changes into kinetic energy.
As the roller coaster ascends the second hill, the kinetic energy is turned back into potential energy, and the kinetic energy and the potential energy is always a constant.
Thanks, Courtney and Rachel. Now on to Professor Kelsey with the Sports Maker's Blackboard.
Thank you, Lisa, Courtney, and Rachel. Now, it's time for Professor Kelsey to explain the physics of roller coasters on the Sports Figures blackboard.
Roller coasters operate on the conservation of energy principle, which states that the total mechanical energy of the roller coaster remains the same, but it can be transferred between gravitational potential energy and kinetic energy. At the top of the hill of the roller coaster, it has no kinetic energy because it's not moving, and the gravitational potential energy is at its greatest because it's at the highest point. To find gravitational potential energy, use the equation Gp equals mgh, where m is the mass of the object, g is the acceleration due to gravity, and h is the height above the surface of Earth. In this case, you have to find the mass of one car, which is about 500 kilograms, and multiply it by 3, since there's 3 cars on the Hurricane. Then you add the mass of the average person riding it, which is about 55 kilograms. So in total, you get 1,555 kilograms. When you put it back in the formula, you get Gp equals the mass times acceleration due to gravity, which is a constant of 9.81 meters per second squared, times the height of the first and tallest hill of the Hurricane, which is 59 feet and converts to about 18 meters. So when you plug all these in and multiply them, you get 274,581.9 joules as the gravitational potential energy at this point and the maximum energy that there is in total. To find the maximum Ke, or kinetic energy, we use the equation 1/2 mv squared, where m is again the mass, and v is the speed at its fastest point squared. The speed at its fastest point we know is 35 miles per hour, which converts to about 15.6 meters per second. So you put all the values in for this, you have 1/2 times 1,555 kilograms times 15.6 meters per second, quantity squared. And you get the kinetic energy to be 189,212.4 joules.
Wait, Professor Kelsey. I have a question. I don't understand. Why is the Ke different from the GPE that you got before?
Well, for one thing, at its lowest point, the roller coaster does still have gravitational potential energy because it's not directly on the floor. It still has vertical position from the ground. So that should add also part to the deficit, which is 85,369.5 joules. In addition, the force of friction acts on the roller coaster, and when external forces act on the roller coaster, they can have negative work that'll take away from the total energy.
Wow. Thank you, Professor Kelsey. Now I get it.
Me too.